Hello, Neil Bertrando here today with RT Permaculture, and I'm here to talk about low-tech erosion control as part of a upcoming course that we have online, uh, looking at the low-tech erosion control toolkit and ways to apply it in your landscape to heal the landscape, store water in your landscape, and improve vegetation and production on your site. So today we're going to talk about very minimal to modest effort interventions on a site that you can make to what I call stop the bleeding. And that's basically to slow the degradation, to buy you some time, to allow you to plan and make larger interventions. This specific technique that we're talking about is starving head cuts of water. And first you'll want to know what a head cut is. So a head cut is the uppermost or the head of an erosion gully or rill. It's the point where water pours over into that gully or rill. So it's the entry point, and that pour over point actually has a very powerful erosion feature. And the process of water pouring over that both scours out the bottom of the pour over, as well as pulls water and soil off of the top of that pour over. So it causes erosion at multiple locations on the head cut while water is flowing over it. And these types of cuts in the landscape, the head cut travels uphill. So it moves up the gully and allows it to propagate towards the top of a hill. So it is the actively eroding point of the gully. So it's very important to stop it from continuing to move up the hill if it is endangering the health of the watershed or any sort of infrastructure. And on this site, which was a project in Temecula, California, in Riverside County, which is Southern California, a hot, dry site. This site historically had been managed by disking and then intensive mowing to manage the vegetation in the landscape to minimize fire danger for the residences surrounding it. This is 400 acres of open space, and it's a project that I worked on with Ecology Artisans in 2016 and 2017. And we were hired by the Homeowners Association through a locally active group of people that wanted to protect and improve the ecology of the open space there. And they weren't designating much of a budget, so there's very minimal budget and also very minimal materials available for this project. There's no rocks on the site. It's all sand for as far as we could find, at least. Any rock had to be imported, so that would cost money. And one of the things I noticed while just walking around the site was that some of the places that historically had been disc, the disc pattern had taken a pattern like this blue line here, which is the disc cut line, and it had cut just a little groove, enough of a groove to divert the water out of this specific head cut location, which is going this direction right here. That's the head of the cut, and the cut is going down the hill. And you can see that there's some plant material as well as sediment accumulating right there. And that shows to me that this is not currently actively eroding. That just this little berm here on the downhill side of the disc line, this furrow, had diverted water around the head cut and starved it of water. And so water was no longer going over the pour over and actively eroding the head cut. Now, this isn't a long-term solution, because if you get a large enough event, water will probably pour over that furrow and return to the head cut and erode it past that furrow, and so no longer will be effective. But this does slow the erosion on the overall site, allow you to prioritize other locations on the site for treatment, and buy you time. Or, this head cut may be near the top of a hill, and so it's not endangering that much. And so you can identify this doesn't need any treatment. It's currently stable enough, and we can move on to another location. So this was just an observation of things that were processes that were already going on the site. And so what we then did, just to train some of the the local volunteers and things that they could do easily, again, with a shovel or no materials, was to take some dirt from inside the gully, just on the banks of the gully, and widen the gully just a little bit, give the water a little bit more room in the gully if it is to enter it. So that will allow the water to slow down a little bit more and not being quite as much of a channel form. So we took dirt just from right there on site in the gully and piled it in this berm uphill of the gully to divert the water away from the gully. In this case, the water is being diverted in this direction. This is downhill here. So divert the water away from the gully and minimize the erosion that is being created by this gully, and basically, again, stop the bleeding and buy time to focus on other areas of the site or things that might need a little bit more attention or intervention. And at the same time, create a treatment that is working currently and actively slowing the erosion on the site and is doable with a very low level of training, just a quick introduction to places to get the dirt from and put it onto the top of the head cut, and just on-site materials and a shovel. So these are an exciting tool to have in your toolbox, basically to just get things going. And again, your cost of failure or the potential for things to go wrong is very, very low with this sort of approach. You're not doing much as far as a treatment, as far as outlay of cost or labor or time. And if the head cut keeps going, it was going to do it anyways. So unless you're diverting water to create a larger head cut, which in a situation like this is very unlikely, you're going to have no major risks associated with this or costs of failure of the structure or anything like that. So you get a chance to do something quickly and then observe and learn from feedback from the site how it actually works over time.
This is great. This is another example of how it doesn't matter what you have for materials. There's always a solution if you can think creatively with the materials you have on hand to build with what you have and to build in a way that makes it work. And I love how you've taken this head cut and you've said, okay, well, we're going to starve it with water because the head cut's only created because there's water. So if we move the water away or if we move it outside of it, you're not going to have that anymore. This is something, from my perspective, anybody could pick up and do, even again, from watching this video. Does this, when you're
Definitely
teaching this, do people get this right away?
Yeah, I mean, the head cuts are things that I think pop out to people in the landscape. So they're some of the easiest erosion features to observe. And they're also some of the ones that are potentially most damaging if they continue to propagate up through the landscape. And they're, because they're easy to see, they're also often ones that if they're treated and they stop propagating, you can get a kind of a quick acknowledgement of the effectiveness of a treatment. And another thing is this sort of technique is very often employed when you're looking at doing integrated treatments across the landscape. So it's good to be aware of and be thinking about it as an option, because many times in a more complex situation or a site where we're actually treating in-channel head cuts, because these are kind of off-channel head cuts, most of these, but where we're treating in-channel head cuts is that we'll actually divert a lot of the water to one location that we can treat very effectively. And there may be 3 or 4 head cuts in a system coming up a gully or something like that. And you can use this diversion of water to starve a couple of the head cuts and treat one very stably with a larger rock type of structure. And so this is a good technique on its own, as well as when you integrate it with a suite of other techniques or treatments along a project.
Fantastic work, Neil. Thank you so much for sharing with us. And yeah, thank you for showing that this is possible with any budget, with any skill set. And if you're interested, if you're watching this video and you're thinking, yeah, that's what I want to learn, check out regenerativeliving.online and take a look at the low tech erosion control course that's coming up in the winter of 2022.